GigaMe Instructor Live Sessions. Today, we take a session on binary search tree.
Okay, so let's start. So before starting, Nitika, I would like to ask few questions on arrays, right? Because we are going to do here the searching algorithms for the arrays, right? So tell me that what are the searching algorithms which are available to search for a particular element in an array?
So like if like we do the normal iteration to find a particular error, like we iterate over the element and we check if that particular error present, then we just return it found. And there are binary search algorithm as well, where if like in that we just find the middle of the array and then we look for the but before that in order to do the binary search, the array should be sorted in a
Sorted,
segment.
exactly.
Yeah, and then only we can perform the binary search array. And we can also do all the like use the array method we have, like built-in method, although they are not allowed to use it, but yeah, just like we have includes or contain, so we can, although the underneath they have the same thing, like iterating over element.
Fine. Okay, I have in between one question. You said that for the binary search, we need the sorted array. That is perfectly correct, right? But how we are going to decide that what particular sorting algorithm, because before that we need to sort that as well. So how we are going to decide that what sorting algorithm is going to be applied there?
I mean, we can, like, mostly all the sorting algorithm in JavaScript are, I mean, they are log and log n. I mean, based on the time complexity, we can use any of the sorting algorithm. The most we have the log n complexity. So most of like mod sort or quick sort, all those have log n. Yeah, it's log n.
Not okay. Let me correct you one thing in here. Not all the algorithms are having n log n, right?
Yeah,
because well, if we'll talk about the insertion sort and selection sort, these are the algorithms that take order of n square as well in the worst case complexity.
Yeah.
Correct. So now let's come down, because we are having basically two sorting algorithms, that is merge and quick sort, right? Their worst case complexity, if I'll talk about in the terms of time complexity, that is almost same.
Yeah.
Right. Then how you are going to judge between two of them that what algorithm is going to be applied?
I think in some cases the order of the element is matter. So in that case, like we don't want to, like if we have same element, right, and if we don't want to make their position or their order to be not as they are presented in the actual array. So in that case we generally use mod sort, and if that's not the case, then we can use like quick sort or quick sort, or maybe,
because that is a very good question, and the interviewers very seek answers for that, because that is where students can get confused. So basically, do you know that we have the space complexity for the merge as well as for the quick sort?
Yeah.
Right. And merge basically requires more space as compared to quick sort. So depending upon the size of the algorithm, there we can choose that what type of sorting algorithm we are going to apply, merge or quick sort. Okay. So while keeping time complexity in mind, we also need to think about the space complexity as well.
Okay, got it.
Got it. Okay. Now let's talk about binary search tree. So tell me, what do you know about binary search tree? What is it?
So in binary search,
why we need to have this in our JavaScript as a data structure?
Okay, so like in order to store like parent or child relationship, we need the binary search tree algorithm. And also, like if we want, and in binary search, like we have the parent node and all its left child should be less than the parent node, and all their right child should be greater than the parent node, I mean the root node, and it should follow for all the levels at the binary search tree. And mostly they are used to store like file directory structure, so that we can easily search through the file directory structure we have. So
okay, you are fine. That is perfectly fine. Don't get nervous in front of anyone, right? Be confident, because you are right. And at some point, if you like you are getting confused, then you can straightforwardly tell about it.
Okay.
Okay. Okay. So in binary, as Kumar has also said that you're very good in binary search tree and all the data structures. So let's start with a few of the questions, more advanced questions, like you must have known about the longest uni-value path, how to calculate that. For example, if you have a binary tree in the form like with a root and all, right? So can you return the length of the longest path?
Okay, yeah, like for that we need to travel all the levels till depth. So we have like three type of traverse we can do. So like pre-order, in order, and post order. So
Okay.
in order to get to the deepest one, so we can use the depth for search algorithm, which include like in order or pre-order or post order, because they follow the depth for search thing. So for that, like, do you want me to write or
First of all, I'm going to share my screen. I will give you the situation in here. Okay, then I have a couple of questions for which I want you to create program as well. Don't worry, we have a lot of questions.
Okay.
Okay. So let me just, 1 second. Are you able to see my screen?
Oh, no.
No, I have shared my screen.
Sure. But no, I can't see your screen. Oh, no,
Okay.
no, I know I can see your screen.
You can. Okay, that's perfectly fine. Okay, so let's say I'm going to create a, diagrammatically binary search tree in here. So let's say we have 5. Don't go on my handwriting, okay?
No.
Yeah, we have 4. We have 1. We have, let's say, again 1 in here, right? Because we know that all the elements are going to be smallest. Then let's say we are having 5 and then 5. Now, what is going to be the answer? Just give me a quick answer that what is going to be the longest path, the length of the longest path in here.
So I think they all have the longest equal length, but I can see, but the condition is like how long. I mean, you want the longest.
Give me the number in terms of number. What is going to be the output? Let's say that you have applied the algorithm, right? Then
I mean the longest. You mean the most depth?
Length. Yes.
Okay, the length. Okay, 1, 2, 3. I think all of them have the long. All are equal, like because 5, 4,
Exactly.
1, 5,
Exactly.
4, 1, and this
Exactly.
5.
So what is going to be the answer? It's 2.
5.
2.
Oh.
Why 5?
No, not 5. No, not 5. I'm just. You mean to say we need give the count of the long? I mean the longest
Yes.
part. Oh.
Length of the longest means we are going to tell the length. That what is the length of the tree?
Oh, okay, got it. Yeah, it's 2. This like
it's going to be 2.
4. I mean the second child and the third, the leaf node. So they are 2.
Yeah, because see, they are basically starting from here, correct? Starting from here, basically. So here 0, 1, 2. So that is the length of the tree, right?
Okay, yeah.
Okay. Now I have one more question, and before I want you to create algorithm for that. And before creating the algorithm, I want you to give the answer at first. Okay. So let's say I want you to give me the maximum width that this particular binary tree is going to hold. Okay. 1, let's say 3, and then let's say we are having 2, and then 5, and then 3. Okay, and then let's say 9. Okay. The maximum width means this part, right?
Oh, this part, the maximum. Okay.
Width, yeah.
2.
How did you deduct it? Why 2?
I mean the maximum width. I imagine like both have the.
Okay, Nitika, look at me. Whenever you're working with any of the thing in any programming world, always relate it with the real entities. You have a tree. Okay. how will you say that what is the exact width of the tree? By measuring that entire bottom,
Yeah.
not just the left part, right?
Okay.
You are here trying to calculate it only on the basis of left part, but the width is going to include the entire path, the entire width of the left as well as the right. Now
Right.
give me the answer.
It's 3.
Okay, now let's assume that you have, Christmas is going to come, right?
Mm.
So you have this tree.
Yeah.
This is a tree. This is a real tree, okay?
Mm.
So in between of this tree, let's say, this part is missing. So can I say the length of, can I deduct this part and then I can calculate the width of the tree, or I will say, okay, this is a part of this entire tree. It is going to be in here. So the length is going to be still the same.
Yeah, it's still the same.
Still the same.
Yeah.
Then why can't we include this part? Whether it is null or not, we need to include this part as well.
Oh, okay.
Now count it. How many the nodes are there on the bottom part? How many leaves are there?
4. I mean,
4.
not 3. I mean, if null is included, then 4. Yeah.
Then 4, right? So the answer is 5, 3, null, 9.
Yeah.
Got the answer that how the answer is 4 in here?
Okay. Yeah.
Okay.
Yeah.
So that's why I tell you that always try to think, from that how the real tree is going to work like that.
Okay.
Okay. In most of the cases, these things work very well.
Yeah.
Okay. Can you create a program for this?
Yeah, let's try.
Okay.
So, but yeah.
Okay. Yeah, I want you to share your screen.
Mm.
So always keep 2 things in your mind, length and width.
Okay. So can you see my screen?
Yes, I can see your screen.
It's code pen.
How do you create it? If I'll ask you that give me a binary search tree, how to create an algorithm, just start with like that.
Okay. So we have.
You can also, if you're comfortable with classes as well, you can also take class.
Okay. Let's start with function.
Okay.
We will be having a root. Let's see.
Exactly.
Okay, so suppose if root is the base case, we need always take care of that. Then we simply return, like if you want me to return null, then we can return null or 0.
I think you should return 0.
0. Okay. Yeah.
Right? Because whenever we're talking about the length or the depth, it always in the numbers.
Yeah. Okay. Yeah. Right. Okay. Okay. So what I am thinking of finding the depth. So because depth can only be defined when we reach to the leaf node or the leaf level. So we will going to count all the leaf node from the left to the right, including all the null as well. So for null, if there is null, we still increment the depth, and we right. So for this, like we can use whichever, like let's use what you say, first order or
okay. I see when you were trying for this function, I believe it is perfectly fine till if not equal to root, then return 0. That's fine. Now what you do now, if let's say that we are going to write width, max width is equal to 0. You're taking one variable here. Okay. Then what you can do, you can take the node from the root value, and then you can take the position starting from the 0 point. Now in that perspective, try to do that. This function is fine. Remove this line number 3.
Okay. No. Okay.
Okay. Come out. And before that, where is your node? You said that you are going to start with the node, right?
Yeah. So no, let's say I want to like draw the triangle. So that no. So let's say we have this 6, right? Or we have 3.
Okay, I'll help with that. Take 1 in the top. 1. Okay, then towards the left side, take 3.
Okay.
Right side, 2.
Okay.
2. Exactly. Then towards the left, take 5.
Okay. And
Okay. Then left to this 3, right to this 3, take 3.
okay. And just keep it blank and what?
Yeah.
will-
And then for the right to the right, you can take 9. The left is not going to be there.
Mhm. Okay.
Okay. So now we have the same situation that I asked the question for.
Yeah, so here
There
is
is one null value here in here as well.
Yeah,
Now
here are root. So root is here, right? And we traverse till we found the leaf node. So as soon as we found the leaf node, we will increment max depth, and we just keep going. And we also check like if any node don't have any left or right child, we still increment our max depth.
exactly.
Right? So
It depends. It is also going to depend upon the length as well, the level.
Yeah.
Right. So we need to think about that. So I will recommend that what you should, rather than creating directly the function, you should first create a binary search tree.
Okay.
Yeah.
It's
so
like
after that, we can call this max depth function to calculate the width.
Okay.
So now come down to after line number 12. Now create one variable for the root, then one variable for the left to left and the right to right. How to do that?
Oh, no, I don't get it.
Okay, you don't know how to create a tree, a simple binary tree in JavaScript?
Oh, you mean to say the class I need to create or just the diagram? I don't get it, like what I need
Proper
to
function, JavaScript function.
Oh, proper JavaScript function.
JavaScript. Okay, so what I'm trying to ask you, for example, const root is equal to what you have. You have, let's say you are creating one class node. Okay, on the basis of that, you are going to create the objects. And in the objects, you are going to fill the values.
Yeah.
Got the idea?
Yeah. So we will be having class and let's say dt, and we will be creating left. No. Okay. The first node. Constructor node, and we will be having
Ritika, can you use this outside constructor?
it's outside only.
Right? We can. Should we use? You're writing this dot node at line number 15 outside the constructor. Outside the constructor, we can create directly everything.
Okay.
Good.
I think we don't need to do that. We just
yeah, I don't think.
We just do not. But before that, but how did it knows like it has left and right?
Okay, I will help you from the start. Okay, it's okay. So let's say that okay, always try to use very simplified versions of the variables. Okay, so class, instead of BT, write node with capital N.
Okay.
Delete BT. Yeah. Okay. So we have class node in here. So what we can do, create constructor. You have already created constructor. So what we need basically a key on the basis of what we can create a entire tree. Right.
Yeah.
So pass because we have already created the node as a class. So pass here any variable like key. Just write here key. Key, exactly, right? Then we are going to have the value. Then this dot value, or yeah, is equal to, you can write here key, right? Semicolon. Always try to put semicolons in JavaScript because companies are very much into it, that whether they are writing it or not. So enter. Then now we have a key. Key is nothing but it. We can think of it as a root. From the root, we always have the left as well as we always have the right. Okay, so what we are going to do now, we need to create left and right. So this dot left, right now we don't have anything, then write null, and then this dot right is equal to null.
Okay.
Okay, so this is the basic template structure that you have created for a tree. Now you want to give the values, correct? So what we can do, we can create the objects for this class. On the basis of that, we can give the values every time. Okay, let me help you with the first one. Let's say you are going to create a root value. Okay, now const, you can write root is equal to new node. Okay, and then that one particular, because now here you are saying node, new node, and then the square round brackets, right? So with the help of this, it is automatically going to call the constructor by default. So that means that key value is going to be passed in there. So that key is going to be the root. So right here, one, the same that we have created in there. Okay. Now create next.
Okay.
Const. Yeah, you can write here. No, that was good. Root dot left is equal to new.
Yeah, new node.
Then
3.
Yes, right, 3. Now create the entire. Now give the entire value for the left to left or right to right. Okay. Good.
Okay, it will be okay. Let's, because now it's node left and
yes,
right. Let's just
till here it was easy, right? Now we are going deeper.
deep.
Exactly. Good. Good.
I think.
Great. See, now you have created the entire, you have given the values for this entire binary search tree. Okay. Now, do you have any doubt in this one?
No.
Now it is clear to you?
Yeah.
Okay, fine. Now, because we are just directly using JavaScript, so I think we can go for the console.log. In the end, just write here, I want to see the value. So to see the value, console.log, and then we are going to create one method up that you have created, and we are going to call that.
Okay.
And go down, where you're calling the method?
I'm calling it here only, so.
Yeah, directly write here next with and round bracket.
Root.
Exactly, root, because it is going to be started from root. Now you are going to create. Okay, this is how we should always create JavaScript programs. From the base, then jump to the conclusion part. Okay. Now create the function. Yes, this line is perfectly fine. Yes.
Let's have max
Mm.
depth
Mhm.
be 0 and so we have here we will go to let's so do you want me to do like iteratively or recursive?
Your choice. Anything. But it is going to start from the length. Depends upon the length. If it has only root, then what is going to be the width, right?
Okay, it all has only roots. So okay, fine. Then we will give it 1.
How you are going to conclude that?
If root dot length. But you said like if still
Use
then
your breadth first search. That's how you're going to traverse the tree, right?
yeah. Okay. No. I am asking like if there is only one, I mean there is only no one. I mean there is the root node, then and nothing below that. So we just only return 1, right?
Yeah.
Right. So for that case, I am writing root node. 1. So let's take depth first search. We have to start. So what we can do? We can do an in order traversal, or I think which one is better in. We need to traverse first the pre-order. Okay, so we can do a pre-order traversal. So what we can do in that, so let's create another function to let's say it's pre-order, and we will pass the root here. And what we for pre-order, like there is no need to look for the value. So if we just simply max depth, we just increment it anyhow and just traverse it. We also don't need to do this. So order root dot, we will check later that condition, the depth. So just first do the basic one. So left and root dot right, and let's see, make it root, and from here we will return them. So and the condition is like there might be a case, suppose just copy this only. So there might be the case like this, where suppose it has say 6, right, and here it says 7, and here it says
You're creating 6 to the left of 5 and 7 as in?
wait, let's say 4, 7, and this node don't have anything, and let's go to this one 8 and let's do this, right? So this has nothing, no left, no right, right?
Exactly.
So in that case, I don't need to increment the depth, right? We just only need to increment till we reach the leaf node of the entire tree.
Okay, give me the answer that what is going to be the answer for this one? What is going to be the width of this?
1, 2, 3, 4, 5, 5. Like if I consider what you mentioned, like 3 is here, and we can also have 2 null. So 1, 2, 3, 4, and 5, 6, and 7, 8, 7, 8, 2. So if we consider all the null value, then it will be 8, right? And yeah, I mean 8. Or no, I'm not sure. Because according to this, it will be 4, right? So I have a question, like do we need to consider if left as, I mean right as well?
Yeah, because in the 2 as well, we are considering the null part, right?
Okay, so
Correct.
but
That if that null was going to was there, then we also it is also going to have the children, right? The
okay.
further, because we need to level up the
Okay.
base. So it is going to include all the null part.
1, 2, 8.
Yeah. Now create the logic for this.
Okay.
Okay, first of all, just create the logic. Let's not make it too complicated. Let's create the logic for this 24th line, like 5, 3, and 9.
So let's print this first, because I think, and if null, oh, we can't return it because here, no, we can. Because this is the case like when we reach to the leaf level. Right, so can we try to print it? Why it is like this? Okay. So I'm getting 6, and 6 is not the answer, right? It should
The logic is complete.
1. No, it's 4. No, it's 6 only. Yeah, it's complete like just for this, but it's counting.
No, we should. Yeah, we should. It should give us 4.
It should give us 4, right?
Go up.
I'm missing something. If
Function pre-order, you have passed node. If node is not, then return. Max depth. Where are you getting the length?
You mean the depth?
Yeah.
Length.
Length. Because it is also going to depend upon the length as well. If it is only root, then the 1, then it is, the length is 0 and 1, 1, then it is going to give us 2 as the answer.
Wait, I think we can pass this. So let's say it is length. This length is the same, and we just let's, and then we don't need to do this. Here it should be. Oh, it's giving 0. God, what will happen is like first we are here. Now next it will pre-order, so it will give this. We just increment depth, right? When we are here, we increment depth to plus, 1. Next, it will go to the left. No. Okay. Because we need to go till leaf level, right? Then only we will be incrementing the depth. It will keep.
You need to recursively call something, right?
Yeah. No.
You have not called anything which is going to calculate everything by itself.
Okay. I am planning to do is like this thing. So just put it here. This thing will just iterate over the tree, right? And if we have root dot.
Also, Nitika, do one thing, provide this code to me in the chat box.
Oh, okay. The whole?
Yeah, the whole.
It's, yeah. If we are at root left root and its left is null and its right is null. Yeah, I don't think we need it. Because max depth is already, it's a closure inside it, so we don't need this. And similarly, we will, so in this case, we'll handle like if we are here, like if we are here, it will check if left, it's left is null, and if it left this, because it's already left, right? So if it's null, then only
it doesn't matter. Again, it is going to count. See, if it is null, again, it is going to count. You're asking me the answer of that particular question, right? That what is going to be the width of that. So whenever you're talking about the maximum width, it is going to consider all the null paths, every null path.
Okay. Still I'm getting. I'm incrementing only when it's null, like it's leaf node, or when it is there is a null both side, like for it's also a leaf, so it will count here as well, right?
Yes.
So it is we are incrementing only when we have null. That take is null. This means it's a leaf node. First condition, leaf node. This is a leaf node. Now, right? This is the leaf node. So now if it comes here, like right, and root, we have this root dot right, and this root dot right don't have this, so it won't go on this. Okay, so if and else if we also check, like if any of the We can check it here.
You try it for 1 minute more and then I'll
Yeah.
give you the solution, okay?
Okay. So what I am saying, like either, because this is the case leaf node, and for this case what I'm checking is like if any of the node is null, but still it's not null, and so it should be the root node, I mean leaf node.
Okay. I have on the basis, because there are several ways through which you can create a single code. Correct. So I have 2 to 3 different approaches. So I have used your approach to get the answer. So I have got the answer as 4. So now what? Okay, let me see your code. You have created the class, then you are have created the go down. Now see the solution. I'm going to share my screen. My screen is visible. Okay, see, I have 3 ways through with the help of which we can deduct that what the maximum width is going to be. So this was the way that I created for me, using I have taken this object, putting the value of node as like root node, and asking that for the position, that where the position is, because it also depends upon the position and the level size, right? So that is the one solution. The other solution is that I have created it, with the help of simply a pre-order.
Okay.
That when you were trying to.
Richa, 1 second before I leave, Nitika, would you be able to cover by next week when you come to the session, like our array and the page array, right? The section array. Under array, like at least 10 pages,
Okay.
If you go 1, 2, 3, 4, if you 10 pages, there is sub-array, there is a multi-dimensional array, nested array, JSON, nested JSON, object and string, array of objects, So you see that maybe you can check with Richard, next time. There were some doubts and questions.
Okay.
Then there is a binary search tree. You can even search that binary search, that you can cover all the binary search tree, and then array, arrays, sub-arrays.
Okay.
That's very foundation actually. Once you finish that, then the other algorithm, because I don't want to directly go the tree and other things. And if you don't cover the basics, foundation, then you will be able to, maybe you are struggling and maybe in the advanced algorithm. I don't want that, Okay. If you cover that basic, then we can go advanced next week. Okay.
Kumar, I think she can also cover, if you can cover, bache, the basics of the binary search tree, like how to just basics to calculate the length of a binary tree, like if the binary tree is given to you, right? What is going to be the width of the binary tree? Try these such type of questions as well. And I will also give you one level for this one, then I'll explain the code to you. Okay. So take this as well.
If you search, like, let me search binary.
Yes.
Binary search tree in our platform. Let's see, binary search tree. Yeah, so if you see binary search tree, recursive insertion, very important. And then insertion in the binary search tree in the boundaries nearest nodes. And then ways to invert a binary search tree. Okay, and the traversal, basically, traversal is important. Traversal binary search tree.
Traversing is important.
Recursive traversal, first traversal, all this. Nearly some like 10-15 question is there. If you want, she can cover next session, with you. If you're busy, you cannot, then she will cover next session, all this basics actually.
Yeah. It's fine. We can cover in the next session as well.
So yeah. Okay. And let's see, like, because I want before your interview, when is your next interview? Next meta interview is on January.
Is on 16th.
Okay. So before that, we should be able to cover algorithm completely and functional programming in JavaScript basics. Yeah.
Okay.
Okay, Ritika, have a good night. Okay. I'll see you then. Talk to you later.
Okay. Bye.
Bye.
Thanks for watching. Want to stay updated and learn more? Follow us on social media.